What's up guys, this is Team One Shot. In this video, we're going to talk about our final goal for our AI project and how we achieved it. As mentioned in our last video, our project topic is to teach the agent to do archery. We finished our baseline in the last phase, which is hitting a motionless target.
Before talking about our final goal, we'd like to mention the changes we made for the environment. Basic environment setting is the same as we have in last video. However, we expand the target cell to a 5x5 square space so that the target is able to move inside of the cell. Our final goal of the project is to kill the moving target using their fewest arrows. We use Q-learning algorithm of reinforcement learning to make this happen. In our learning system, we define target's 2D position and 2 moving directions as its states, its aiming angles, and decision of whether to shoot as its action. About reward, if the agent chooses to shoot, he will get 5 points deduction first. The agent will receive 22 points as a reward for hitting the target, 100 points for killing the targets. Otherwise, he will get another 10 points deduction. Besides shooting, agent also can hold the arrow, and in this case, he will receive 0 points.
Now I'm going to talk about our algorithm. We use the Q-learning in our case, which maintains a Q table that will give a score for each state. Our agent will choose the possible actions based on the best score it can get from current state. After every action made by agent, the system will give a score based on Q-learning formula to update the Q value for current state. The formula is new Q value equals 1 minus alpha times old Q value for current state plus alpha times sum of reward just get plus discount factor times estimate of optimal future value. There are 2 different ways of state transition: mob moved by himself, mob state changed by the arrow hit him. So the future state will choose differently based on each case, and their optimal future value will also be different. We choose 0.4 as our alpha and 0.2 as our discount factor. For epsilon, we use the greedy epsilon approach that decreases epsilon number by 0.1 for every 10,000 actions we trained. In our case, we start from 0.6 to 0.3. For more details about algorithm part, please check our report.
It's the demo time. At the beginning, we can see that agent does not aim at the target very well, mainly because our Q-table hasn't been filled in with its current data yet. The agent will keep shooting the left bottom corner because the angle returns the biggest value of each state based on our empty Q-table. After a while, agent can hit the target in some steps, and we can see the agent might wait a long time before actually shooting it because holding arrow from the specific angle can give us a higher reward than shooting it. At the end, we can see that the agent can kill the target within first 3 shots in some situation. However, our epsilon value is not 0. Agent can still choose its action randomly.
And that's it, we achieved our final goal, yay! We have all the code we implemented published on our GitHub page. Feel free to check them out. Again, thanks for watching and happy holiday!